Hi, welcome to Conquer the Concept, and in this video, we'll learn how to graph quadratics in the vertex form. So we know that general quadratics are in the ax squared plus bx plus c form, but quadratics can also be written in the a times x minus h squared plus k form, in which h comma k is the vertex. The a here is the same as the a here, and the x here is the same as the x here. So the only differences are the h and k, which represents the vertex. Let's go to a problem to see how we can graph a parabola, something in the vertex form as a parabola. So the problem is y is equal to 1 times x plus 1 whole squared minus 4. We're going to graph this into a parabola. So the first step is to identify what the vertex is, which we can do by identifying what h and k are. So h is equal to 1, h is equal to negative 1, and k is equal to negative 4, right? So the vertex is negative 1 comma negative 4. So if we plugged in negative 1 here, then into the general a times x minus h squared plus k form, we would get this. So let's graph negative 1 comma negative 4 on our graph. So negative 1, 2, 3, 4. So that's where the vertex is. So we also learned in a previous video that this negative 1 here is the line of symmetry, which is the axis, the line of symmetry, and the average of the two roots. So if one root is 5 and the average is negative 1, then the other root would be negative 6. No, I mean negative 7. So let's so ideally the next step is to find what the y-intercept is. We can do that by setting x is equal to 0, because on the y-axis x is 0, so it's always written as 0 comma y. So let's substitute x as 0. So it would be y is equal to 1 times 0 plus 1 whole squared minus 4. So we can evaluate this further to be 1 times. We don't really have to keep on writing this one here, but I'm just writing it for clarification. 1 squared minus 4, and it's going to be further evaluated to y is equal to 1 minus 4, which would be y is equal to negative 3. So let's graph that. So if y is equal to negative 3, then that's 1, 2, 3 right here. So y is equal to negative 3. So now we know that parabolas are symmetrical. So that means if you fold the parabola in half on the axis of symmetry, which is negative 1, then we would get two identical pairs. So the point that corresponds to negative 3 on the y-intercept here is the 3 comma negative 3 comma negative 3, because do you see how they're symmetrical? And if I divide it on this line, then it will it's basically the same point. So now we kind of have enough information to graph our parabola, but if you want to find the roots, we can also do that. So when we're finding the roots, that means that we're finding the place on the x-axis where on the x-axis where the parabola intersects. So that on the x-axis the y value is 0. So previously I stated that on the y-axis the x is 0. Now on the x-axis the y is 0. So if we equate this vertex form to 0, like I did here, then we can evaluate for x. So 0 is equal to 1 times x plus 1 whole squared minus 4. So if we add 4 on both sides, we would get 4 is equal to 1 times x plus 1 whole squared we can divide by 1, which really isn't necessary, but it's for clarification. So this 4 over 1 is 4. 4 is equal to x plus 1 whole squared. If we take the square root, which is the opposite operation of square, then we would get the square root of 4 is equal to the square root of x plus 1 whole squared, which would be 2 is equal to x plus 1, and then we would get 1 is equal to x. So if 1 is 1 point on our x axis, and we know that parabolas are symmetrical, and when you flip them on the axis of symmetry, which is -1 in this case, they should match up. So if we find let's find the corresponding value to 1 on the x-axis. So 1 is 2 units away from -1. So we have to go 2 units to the right of -1. So if we let's go 2 units to the left to find the corresponding point. So 1, 2. So this is our corresponding place. And now we have 5 points on the parabola, which is enough to tell us it's enough to tell us like what the parabola will look like. So we can graph it, and the parabola would look something like this or this. So that's what the parabola would look like. And if you like this video and learned, please and please subscribe and comment down below. Thank you for watching.